Hey everyone, this is the Deliverable 5, the boat trip project. I'm Mustafa Zaidi, and I'll be introducing you to what this boat project is about and how our team approached it. This presentation highlights a real world issue on how electronic devices are affected when used in marine environments, from saltwater corrosion to sonar interference, and we explore the key chemical and electrical challenges engineers face at sea. So about our team is made up of three members. Mika, who is a team facilitator, and the product manager, who made sure everything stayed organized and on track. I'm Mustafa Zaidi, and I took the role on as the team manager and tried planning everything. And then finally, we had Connor, who was our research facilitator, digging into technical side and gathering key resources for us. And we all played an important role to moving this project forward. So this is our initial proposals. At the start, we brainstormed several possible issues related to electronics in the ocean. We looked into corrosion, since seawater causes metal parts to wear down quickly. We also considered how ocean conductivity due to salt content affects electronics and signal transmission. And other ideas included the risks from battery chemicals, the use of pollution sensors, and how sonar can be disrupted by seawater chemistry. After narrowing it down, we decided to go with the most chemistry heavy and widely relevant issue for our final topic. Our final proposal, as you can see, focuses on the high conductivity of saltwater and its impact on electronics. It's a widespread issue that affects ocean tech across industries, from underwater research to naval equipment. Since this directly ties into chemistry and electrical engineering, we felt it was the strongest topic to explore in depth. From here, Mika and Connor will dive deeper into the science behind it, the issues, and explain the real world implications. And that's it for me.
Next up, we will be talking about the findings on this boat trip. First, we have the Gulf sulfur, which significantly impacts corrosion chemistry by forming compounds that accelerate metal degradation, particularly in wet environments. It can react with metals to form sulfides, which are then further oxidized to release sulfuric acid, further accelerating corrosion. This process can lead to localized corrosion like pitting and hydrogen permeation, which can weaken steel. Next up, Gulf copper. In some cases, copper can be corroded, particularly in marine environments such as Galveston, or when it is exposed to acidic or saline solutions. However, copper also exhibits resistance to corrosion and can even act as a corrosion inhibitor, especially in the marine settings. Next up, we have the SS Selma shipwreck. This shipwreck contains steel reinforcing bars and other steel components that have been exposed to these conditions, leading to corrosion, obviously, which is a chemical process where metals react with the environment, causing them to degrade. So it's not all there too well. Next up, we have the mooring buoys. Corrosion, that is a chemical process where material is degraded by its surroundings. It is a major concern for the longevity and safety of the mooring systems. Seawater, with its high salinity and presence of oxygen, accelerates corrosion, especially galvanic corrosion. And finally, the old Galveston Causeway. Its earlier concrete and steel sections experienced increased corrosion due to the marine environment's high chloride levels. This led to the need for interim repairs, including footing repairs in 1979 and temporary repairs in 1999.
And so finally, we're going to talk about some evidence that backs up what we're saying. So first of all, corrosion is a very widespread issue. One study from 2017 estimated global costs of around 2.5 trillion USD from just corrosion-related issues. So it's really something that we can't escape from, especially so close to the ocean, and particularly with electronics close to the ocean. Those small components in electronics are really susceptible to corrosion, and they can fail very quickly, which can be very detrimental to industries for their just basic functions, as well as transportation, like we discussed with the Galveston Causeway. So how can we prevent this issue? One way that's common is to apply a thin coating over the surface of the metal, like we see in this picture here. This coating seals the metal from the outside oxygen that it reacts with to form the metal oxides. And it also can shield the metal from the really high salinity ocean water. It reduces the reactivity of the metal. It also doesn't need to be reapplied very often, which makes it a very cost-effective solution. And corrosion also has negative effects on marine life, which is another reason that it really needs to be prevented as much as possible, especially in ocean environments. The process we see in this image involves metal ions combining with oxide ions from the water, and these excess metal ions and metal oxides that fall away are released into the water, which can be very toxic to marine life in the area. And these reasons are why electrical engineers that are planning a project that is in or near to the ocean really need to take corrosion into account, as their failure to do so adequately can and will result in the failure of vital components for the operation of the project, which can cause interruptions, and it can also harm the marine life in the area, which right now really needs to be protected more than ever. And yeah, here's some of our references. Thank you for watching.